Woo! Alright, inverse functions as promised. Okay. We're going to do a problem, and it wants us to find the inverse, find the domain and range of the inverse, and then check and show by plugging in our inverse to our function and our function into our inverse and making sure that equals x. Okay? Now, I'm going to go ahead and go through this step by step. Go ahead and be ready to take notes if you need to, or rewind, pause, whatever you got to do. But we're going to go ahead and be doing it with this problem right here, this function, of function of x is equal to x to the 5th power. Alright, now let's get down into it. F of x is equal to x to the 5th. And we're going to go ahead and, man, that's ugly 5. Bear with me, guys. Anyways, we're going to go ahead and do the inverse. So the first step that we got to do is we got to change this function of x and make it a y. So let's make it y. Y is equal to x to the 5th. Alright. The next step, and this is going to be a funny looking arrow too, but that's an arrow if you want to believe me or not. The next step is we want to solve for our x. So we want to get x by itself. That's what that means. So how do I accomplish that? If I have a 5th power of x. Well, all we're going to do is we're going to do, what's the opposite of taking something to the 5th power? It's taking the 5th root of it. So I want to take the 5th root of this guy. And remember, whenever I'm solving equations, whatever I got to do to whatever I do to one side is what I have to do to the other. So I got to take the 5th root of this other side. Now what happens here is this 5 power to the 5th power and this 5th root of power, okay, they're going to go away, and I'm going to get an x. So I'm going to go ahead and put x on the left side. Does not really make a difference. Is equal to the 5th root of y. Now here is the last step. Okay, once you've done this, you found the inverse. Congratulations. Alright. Now x is going to get interchanged, and we're going to write f inverse of x for it. And then where we have our y, we're now going to put an x, 5th root of x. And that's it. That's it. We already did the first part of that question, finding the inverse, right? Now the second part is find the domain and range. How do we do that? Now there's a really easy step to this. There's a really easy trick to it. If you want to find the domain and range, all you got to do is find the domain and the range of the original function, and then you're basically just taking the opposite of what it is. So your domain of your original function will be your range of your inverse, and your range of your original function will be your domain of your inverse. Again, I'll say that again. If you find your domain of your original function, that will be the same as the range of your inverse. And if you want to find your range of your original function, that will also be the same as the domain of your inverse. Okay? So let's go ahead and just find the domain and range of this, and we'll get the domain and range of our inverse. Alright? So if we have our original, right? Let's find the domain and range of this. Our domain, are there any restrictions? Do we have any radicals, any square roots, any fractions here, anything? We don't, right? So that means we could plug in any x value. There could be any x value for this. I could have anything in there. So that tells me my x value, this is from negative infinity to positive infinity, if we wanted an interval notation, or maybe it might want it like this. But it means the same thing. Okay? That's our domain. Now our range, let's find our range. Now, are there any restrictions on what our range is? Basically our y, right? Our function of x, which is y. If I have an odd power, that means I could have negative value in there and a positive value in there, depending on what I plug in there. So really, there's no restrictions again. Our range of our function is again negative infinity to positive infinity. And this is why I plugged the y value in there. Again, if you want to use this notation, interval notation, you can. It really does not make a difference. It's the same thing. It's stating the same thing. Now, what does that mean for our inverse, right? That was what we were wanting to get the whole time. So now that we know the domain, guess what? That's now going to be our range of our inverse too. So we already know it. We already know our range and we know our domain, which is our range of our function. So our range of our original function is our domain of our inverse. Okay. Now what's our range? Our range is our domain of our original function. Now in this problem, it just so happens to be the same. You actually end up having negative infinity to positive infinity either way. But that's what our domain and range are for our inverse. Now let's go back to the last part of the question. It wants us to check that it is an inverse and show that when we plug in our inverse to our original function, that's what this means, it should equal our inverse of our, plugging our original function into our inverse, and that should also equal to x, okay? They should both equal to x. That's what this is saying. Let's go ahead and try it out and see if that is the case. So we know our original function, and we now know our inverse, right? Now, let's go ahead and test the first part. Let's plug this into our x, to our original function. So how you notate this is going to be as such, right here. So where our x is, we plug this guy into there. So we're going to have the fifth root of x, and this is going to be to the fifth power. Now what happens here is these 5s, they go away, and we end up just having x by itself. And the same thing, now I'm going to plug my original into my inverse. Okay, my x were for my inverse. So how you notate that is this. I'm going to go ahead and plug it in. The x to the fifth there. And what happens? The same thing. The 5s, they end up going away, and we end up getting the x there. Now, do they equal each other? 1. Yes, they do. Do they equal x? Yes, they both do, right? They both do. So what does that mean? That means that it is a 1-to-1 function. Alright, and that's how you work out these problems with those kinds of instructions. We can go ahead and go into derivatives of inverses now. Okay, if you want me to work out another problem like this, just let me know and I'll be glad, more than happy to help you out and go ahead and work out one for you. But the next video is going to be derivatives of inverse. Thanks.